Well, here we are, and a specialization of should work, but it doesn't. And I have no idea why. Maybe it does not work because I'm trying to use it on unlocked inside. Oh, this unlock base. That should not be a problem. Unlocked is already fully defined. That ends here. Unlocked template, two template parameters. Yep. Why would that not work? This gives me no matching function for call to unlocked cast in instantiation of member function. Note candidate function would lose const qualifier. Excusez-moi, which one is that? Cost. Well, okay, so we also have one that is const here. Candidate template ignored. Constraints not satisfied. With you is thread safe unlocked something. Maybe it's the reference. The reference? Oh, it's the reference. Oh, okay. That doesn't say that, but totally, that's hopefully it. Yeah, I'm an idiot. Type name, remove reference view type is another remove reference underscore t. And you don't need the type name anymore, I suppose. At least not there. Remove CV ref. The type T of a reference type provides the member type div type, which is the type referred to by T with its topmost CV qualifiers removed. Otherwise, the type is T with its topmost CV qualifiers removed. I think that's what I need. And then we also have a T. remove a reference. Yeah, I need this. Did not help. Oh, that's actually correct. That is correct. So it did work. Now it's not locked. Sorry, it's not unlocked. It's unlocked base where it stops. This is what I wanted. So now I can make a duplicate of this. And now we do is a specialization of unlocked base. How do I cast an unlocked base to another unlocked base? To this unlocked base. Well, unlocked base can be constructed from another unlocked base. But it's derived from. T is derived from base. But it is the other way around. So that would not work. This is an unlocked base reference. If I also had one for an cons reference, maybe, but Yeah, and it won't work because then I don't have my mutex. Hello, Bokchi. I think I just need one that does this swapped. Hello, egg. Why is it so hot here? 26 degrees. Unlock base. Do I change something here or not? On this one. Not really. This needs the cast, static cast to base pointer. The rest can stay, but then we have if base and T are the same thing, something goes wrong. So yeah, let's say and not standard is same. Yeah, it's a V. Same underscore V. Now we can construct an unlocked base from another unlocked base if that wraps a pointer to a thing that is the base class of base. Where is that thing? No one knows. Gone. Oh, yeah. Standard piecewise construct, yeah. Caused. I don't think I need a cast here, right? Cast is not part of the constructor. In fact, I don't need an embase. I don't want an embase. I just want to return rig. Do it like that. Yeah, yeah. Yeah, I don't know, man. Let's make another copy. So the difference between the first one and the second one here is just that it doesn't take a const reference. defiler. That make sure that the template is only considered when the things that you list there are true. So if you assume that requires is not there, then you have a chance that it says, well, this function matches what I'm looking for, and then it will use it, of course. But if you add the requires, it's going to say no, this is false, for example, this is false, and then it won't consider it. So it's more like the function isn't even there. And that's then not an error, of course. It just will continue looking for another match. I don't see really the difference between these two. This one takes a const reference, this one doesn't. But the return type is the same, and the body is the same. Why do I even need a non-const reference then? So of course then you would say, think, well, then delete it. But it can't be that we have to delete it. It just can't be. Something is wrong. So U is a specialization of unlocked. I think it must be a specialization of unlocked const, maybe. Is that bullshit? No, I did remove the const here. I think that the thing is that I want this to be, yeah, const, maybe. Something is wrong. Totally wrong. Going to try that. That's nonsense. U is a reference. Oh, U is a reference. Yeah, it must be a const reference. So maybe the U here that we return is a const reference. Yeah, that's what I want to check then. Say U is a non-const reference. Then I would go from a const reference to a non-const reference, which is wrong. However, I could guarantee that this is correct if I just use a static cast here instead of a const cast. So say I'm casting something that by itself is already a const thing, then it allows me to cast it to a const reference, but not to a normal or non-const reference. So this is a pointer, and then the dereference operator here, the star, makes it a reference. So if this mbase here is a non-const pointer, then I could accidentally cast it to a non-const reference, but it must be a const reference, which I'm not checking for. I should have here is const reference. I'm not even sure. Maybe that exists. That would be nice. And I don't have to do the other thing. Blah, blah. Suddenly we didn't have anything anymore. No, there it is. Const reference is const. Yeah. So we can only test is const after removing the reference, maybe. Yeah. The hell. Is reference and standard is const v or not? Why not? Standard remove reference type u and defiler, yeah, almost the same thing. I don't think I need declaration type. U is just a type. No, that should work. Yeah, so now U is a const reference. So if then since U is already a const reference, this is working. Yeah, take a const reference, return a const reference. The constness of U, although it should be something that is not const, it's just a reference. But okay, this one takes a non-const reference and we return, well, whatever, a reference. It should be non-const, I guess. No, well, why not? Let's test it specifically, explicitly, I mean. So I don't want this to be const. And here we take a const reference again, so then this must hold. And here this one must hold. Error parentheses are required around this expression in a requires clause. Nobody knows why. What the hell? That doesn't make any sense. Yeah, that's what it says. No matching constructor for initialization of .graph item. In instantiation of function template specialization thread save unlocked graph item. Unlocked const thread save unlocked base dot item reference requested here. Okay, let me reread that. No matching constructor for initialization of CVP graph is .graph item. And apparently it tries that for an unlock thing. Nobody gets it. In instantiation of function template specialization, let's save unlocked. This is super suspicious. Why is the cons here? Nobody knows. Nobody knows. No matching constructor for. Yeah, you have to guess that this is the type of subgraph is a cons item pointer template graph item reference. I can't say that this is very easy or very intuitive API anymore. I think what is wrong here is that the IBP first second has a certain type, and I don't know what that type is, but I can get that here from items, IBP, items try in place, returns an iterator boolean pair, where the iterator is the first thing, of course, pointing to a standard pair of the key and the value. Items is a map, so then first second is a const item pointer, and I think it's non-const, so that is an a reference. Oops. So I have an item pointer here, which is a reference. That would be this part. Just make it 2 lines so I'm sure that it is a, I'll call it const item pointer. So this compiles, and I guess that this is the type. So that did compile that part, this line. So this is the type of the second thing. And then we do a cast to a const item pointer template of graph item. I think that's not correct. I have no idea why that even compiles. So a const item pointer template is something that is derived from a const item pointer. Right, okay, so the static cast is allowed. Yeah, I can go from here to there. So this is a reference, and then we cast it to a derived class, basically. And that should be correct because it is a graph. And even it isn't, it is not a runtime error, it's a compile error. So I'm going to assume that this is correct. And on the subgraph is simply what we just casted it to. This thing, that thing. And then we call item on that. So now I call item on a const item pointer template graph item. That would be this one. So that returns an unlocked type. Const reference. But the unlocked type is the unlocked type that we got from const item pointer. Yeah. Which is the unlocked defined in item dot item. So this one. That one const reference. It was a dot item. How many graph items do we have? Oh, this is already inside dot. And the item locking policy is defined here or not? That's inside graph item. If item is defined, then we have it. Suppose item is defined here. We're using it. And then calls reference. And that was the item. How do you go back from this? No, still the same error. Deity, okay, you too. The only reason I can think of that this goes wrong is when this unlocked type is not equal to this type. It's not an unlocked base. Because apparently you have to do with an unlocked base here. And the unlocked type defined in graph item is just unlocked. Aha. That's why it doesn't compile, man. I'm not sure in which cases I need to use unlocked type. Sorry, when I use unlocked or when I have to use unlocked base actually. Gross item is an unlocked. Edge 2. Item pointer 2. That's ridiculous. Graph 2. No, item pointer. Item pointer is the same as item, which is a base. So what is this? Well, yeah, because of this new, I guess it should be an unlocked. Can't pull base class pointers out of the thin air. So that one looks right-ish. What about this one? This one and this one. So that one is the one that I was wondering about. And an edge might be equally wrong, and except that a graph item, is that not just a non-base class? Feels kind of like non-base class-ish. So yeah, item pointer template. Let's say that has an unlock type that is just unlocked, which is necessary because it creates a new one. And item returns that, which is the whole idea of this being a template, that we just cast it back to whatever it was. Item returns an unlocked, and then from that item I'll create a right access type, therefore this one must also be unlocked and not unlocked base. And it is because graph item uses an unlocked and not an unlocked base. But then we get a problem here, because now this is an unlocked and not an unlocked base, while this item is an unlocked base. Why is this item an unlocked base? Because this is returned by function item on subgraph where subgraph is the type const item pointer template. What is the difference with the other one? This is a const pointer template. The other one was a graph pointer template, or no, I forgot. Item pointer template. Yeah, which is an unlock base. This must be an unlock base because item is a base class. And const item pointer is therefore using an unlocked base as well. Therefore const item pointer is just inheriting that, but that's not correct because yeah, we have item pointer, which is also has a also derives from const item pointer, which has that same thing defined here, and then we override it with an unlocked, and we do not do that here. So that was missing. No, well, I'm added. Let's add that as well, even though it's never used apparently. No, makes sense-ish. At least I had this. It should also be there. But should it? Because this should be an unlocked one because we have a new. This one does not have a new. But it gets constructed from a T pointer. No. Let's just try to compile it. Okay. The valve conversion from const item pointer template unlocked type. AKA unlocked graph item to construct save unlock base. Yeah, I just changed it. This is what I was testing. So I changed this away. And even more, it's now I think a graph item, right? I'm now calling item on a const item pointer template, and that is then an unlocked of whatever you pass as a template parameter. So yes, that's now the correct type of item. And then we get no value conversion from .node pointer. Well, we passed that point. That worked. It's even compiling hello world now. We're getting there. No value conversion from .node pointer aka item pointer template .node item to const.port. I thought port could be constructed from a node pointer. Candidate constructor, the implicit. Let's skip the implicit ones. Candidate constructor not viable, no known conversion from node pointer to. Oh, that takes an access type instead of a port. Port. Oh, port takes no longer a node pointer, it takes an unlocked type CRED. Is that true? Oh, right. Yeah, well, I mean, it needs to read the .id from it, so might as well pass a locked an access type. So that would be the node item passed to a port. Now must already be unlocked, or must be an access type. And the error started where? Here. So I would say I have already unlocked it. I suppose I do. And that should work. And 2 and then 10. This is a right access type. You can pass a right access type to a CRED. I'm leaving it. And then we get same error at line 144. Set nodes, remove unlocked. Hello world 144. Error type dot table node pointer unlocked type what? Aka access thread save unlocked dot table node item does not provide a subscript operator. Yeah, the download pointer has here the subscript operator, which is giving me a port copied from item index temporarily locked. I don't think port is any. It's just a type ID. Sure, that should still have been unlocked then. And it compiles in 3 days. Only 3 days to make it compile, huh? But it's not going to work. I bet on a deadlock. Oh, we're in a third. Okay, got lost. Inhibit deletion Vulkan's assertion not can cause immediate allow deletion. Failed. Okay, let's run that in GDB then. Run. Up. So we call this an incremental reference count for the first time. Previous count is still 0. But this falls, so it can be immediately followed by an allow deletion, which then would destroy the object. Up, that is being called from here. Stop destruction of a boost intrusive pointer. The points to unlocked from destroying it. This is inside unlocked, I think. That has to be, because that's the base class thingy. So yeah, in unlocked base. And yeah, we should only be constructing an unlocked base when an unlocked exists, which means that the previous count should have been larger than 0. So this is very suspicious. Why does this happen? Why do we get here? It just creates an unlock type. So we created an unlocked, which then immediately wants to create an unlocked base, which is then the first one to increment the reference count. New unlock type. To the base class. Thinking could wrap this into a boost intrusive pointer, and then dereference it. The double dereference. Item pointer. Probably a base class of item pointer. Yeah. Man. Yeah. Yeah. I think I have to stop because too tired. Now we have a deadlock, as expected. That's called progress. I would rather see an assert, but I'm so fucking sleepy. I'm really literally falling asleep here. So I guess I better stop.